Hello friends, welcome to Blessed Excellence Center. In our last class, we looked at reaction of Grignard reagents with esters. In today's reaction, we're going to give attention to the reaction of Grignard reagent with epoxide. But first of all, what is epoxide? Epoxides are molecules, organic molecules that are formed when one carbon atom in cycloalkane is replaced with oxygen. Now let's see how it reacts with Grignard reagents. Now this CH2, single bond CH2, then oxygen on top, is a typical example of epoxide. And because it involves two carbon, two carbon is 8. So we call this ethane epoxide. So you see it's in a ring form. They are actually ring molecules of which carbon atom is replaced with oxygen. So carbon is supposed to be here if this is if you had to call this cyclopropane, but because the carbon here has been replaced with oxygen, it becomes ethane epoxide. Okay, all right. So let's see how it out this Grignard reagent. This is methyl magnesium chloride. It's a Grignard reagent. Now, usually following the basis of reaction mechanism, there is a bond between this carbon and this oxygen. So the bond will be clipped this way as the arrow illustrates. When you clip the bond this way, according to the direction of the arrow, the oxygen here will be negatively charged, and then this carbon will be positively charged. Coming to Grignard reagent, the bond between methyl group and magnesium will be clipped. When you clip the bond, methyl group will be negatively charged, while magnesium atom will be positively charged. The next thing is for them to exchange their charges. This arrow illustrates their bond cleavage, okay? Then the bigger arrow here is showing you the attachment, the direction of the attachment. This metal group in red is negatively charged, so it will be attached to this carbon that is positively charged, as the arrow with blue head illustrates. And when you attach that, you have going to have this CH3 here. You can see this CH3 is what is here. Then this CH2 is what is here. This CH2 is what is here. This oxygen is what you have here. Now the oxygen is negatively charged, so it will be attached to this magnesium chloride that is positively charged, and that leads to the formation of this oxygen and this magnesium chloride. This is actually an intermediate that is formed in the course of the reaction. Remember that reaction of compounds containing carbonyl group with Grignard reagent, it's actually a two-step reaction mechanism. So this is the first step. Now let's look at the second step of the reaction. In the second step, we bring down intermediates. The intermediate that was formed in the previous step, precisely in the first step, is repeated here. CH3, CH2, CH2, oxygen, MgCl. Okay, the intermediate. The first thing you do is to break the bond between the oxygen and the magnesium, and that gives oxygen a negative sign and magnesium a positive sign. Now this is water that is added in the presence of an acid, so we call it acid hydrolysis. When you break the bond in water, you're going to have hydroxyl component be negatively charged and hydrogen be positively charged. The next thing is for them to exchange their charges. This oxygen here is negatively charged. This hydrogen is positively charged. So the hydrogen that is positively charged will be attached to the oxygen that is negatively charged, and that leads to the formation of this OH here. Remember, every other component here is repeated. This CH3 is the CH3, CH2, 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 CH2. So this is the OH that is formed from the combination of both positive sign and negative sign. Okay, good. Now the OH here that is negatively charged will be attached to this MgCl that is positively charged, and that leads to the formation of HOMgCl, which is hydroxy magnesium chloride. So we call this propanol. It's actually a primary alcohol because the carbon bearing hydroxy group is bonded to only one alkyl group. So that is how epoxide reacts with Grignard reagent. Thanks very much for watching. Do wait to subscribe to our channel at Blessed Excellence Center. Beck.